Hello and welcome to your first PowerPoint video lesson for the Science Prep course. A couple things to go over. First off, you should have received a package of module notes for the first module. And in there you will find PowerPoint video notes to use for each of the videos. Now your teacher may ask for these at the end of each session for a participation mark. So it's a good idea to fill out these as you watch the videos. Videos are no longer than 10 minutes, between 7 and 10 minutes, and it'll just provide you with some of the information for the lesson. Now you'll notice that some of the pages have a little pencil in the top right-hand corner. This pencil means that the note on this page is to be recorded on your piece of paper. So therefore, you might want to pause the recording at that point, get down the note, and then, come back. Now that being said, you can copy down as much as you want. These notes to fill in are simply a guide just to help you get down the information you need. Okay, so let's get started. For this first lesson here in this video, we're going to take a look at the scientific method. So to begin with, what I need you to do is think about what the word science means to you, and then think about what the word method means to you. And if you want to, again, pause the recording, jot down a few ideas, great idea. And when you're ready, come on back here. Chances are, if you gave those two terms a thought, you came up with something like this. Science is the study of the structure and the behavior of the world around us. So it's not only observations, it's also experimenting with both the living things, so animals, plants, bacteria, to the non-living things such as the universe, as large as the universe is, and maybe you even thought as tiny as an atom. Now a method is an order or a process or a checklist. So when we put all that together, we get the scientific method. So it's a way to provide logical steps to solving a problem about the world around us. So a more formal definition, and you'll notice here in the right-hand corner, this pencil. So this you need to get into your notes. This is from dictionary.com. The scientific method is a well-documented, carefully controlled experiment that applies logic, order, and critical thinking skills to solving problems and finding new information. In a nutshell, it's a good way to solve a problem about the world we live in. So let's take a look at the steps involved. You'll notice again the pencil here, and you'll notice on your paper there are 6 steps to fill in. So we're going to take a look at number 1. So the first step is to have a question. Maybe you observed or noticed something or some sort of problem you want to study. That's the first. The curiosity begins this whole process. Step 2 is actually taking the time to research your problem. What do we already know about it in our collective human knowledge? It'll help you make sense of the problem. And scientists do this. They think quite logically about investigating a problem before they move on to step 3. So step 3 is the hypothesis. Now you'll notice you have a fair bit of space to jot down some notes here. So the hypothesis is an educated guess. Educated because you spent a fair bit of time in step 2 researching your problem. It's an answer to the problem, the original problem you came up with. Hypothesis is a statement. It's not a question. You've kind of figured it out. You can test it. You write it in simple terms. If I do this, then this will happen. Because you spent the time researching and because it's testable. That's a big thing here. It must be testable. Now, to make something testable, you have to have both a control and a variable. So the word control simply means something you watch. Maybe you have your thumb under. You keep it in check, right? So controls are constants. They're things that don't change in your experiment versus the variable. And the word vary is in variable. If something varies, it changes. So to have a good hypothesis, you should have some sort of a control, something that's staying constant, and something you're testing. Now what I have here are just a few examples of a very simple hypothesis, and we'll kind of take a look at what's wrong with them, and then we'll move over to the good side and look at why it's a good one. So to get started here, water can be made to dissolve different amounts of sugar. This isn't good for a couple of reasons. It's not testable. How do you change water to dissolve more sugar? Well, you need to provide those controls and the variables. Okay, here's another one. Does raising the temperature of water allow for more sugar to dissolve? Okay, well, you're thinking. That's the problem in the question. But it's not a hypothesis, because hypothesize should be stated as a question. Sorry, they should be stated as a statement and not a question. Here's a good hypothesis. If the temperature of water is raised, the water will dissolve greater amounts of sugar. This one's pretty good. Why? It's written as a simple statement. If I do this, this will happen. We have a control. The control is the water. You need to keep the same amount of water, right? The variable is the temperature, and what we're testing for is the amount of sugar that's dissolved. Okay, so let's move on to the next step, step 4. Step 4, you need to test your hypothesis by doing an experiment. Now, sometimes experiments don't actually do what you want them to do, and that's okay. If it's going well, keep going. If not, well, rework it. Figure out something else that will be able to test your hypothesis. Step 5, analyze your data. Draw conclusions. What's going on with your experiment? What can you deduce from this? Does it match your hypothesis? And you know what? If it doesn't, no big deal. In fact, that's good. That means you've disproved something else. You're that much closer to what it is you want to figure out or discover. So, to paraphrase a famous quote by Thomas Edison was trying to commercialize the light bulb. And the story goes he tried almost 1,000 different materials to figure out what would make the most luminescent bulb. And this is the quote that we often see by Thomas Edison. And it says, "I have not failed. I have just found 1,000 ways that won't work." So in his mind, even though it wasn't working, he wasn't getting the results as he wanted, the closer he got to his answer was because things failed and didn't work as he went. Step 6, communicate your results. A lab report, depending on what you're looking at, maybe you even get published in a journal somewhere. So here we go with the pencil in the corner. This is a nice flow chart of the scientific method. Ask a question, leads to some background research. You'll notice the arrows go back and forth here. Sometimes doing some research can fine-tune your question or bring up new questions. Once these first 2 steps are completed, you construct your hypothesis. You move on to your experiment. Is your experiment working? No? Well, troubleshoot. Go back, check your steps, start again with the experiment. Is your experiment working? Yes. Super. Analyze data, draw a conclusion. Did your experiment align with the hypothesis? Great. Communicate results. Did it, I'm going back here, analyze data and draw conclusions. Did it align with your hypothesis? No? No big deal. That's great as well. Just come on back up and conduct another hypothesis. Okay, I'm going to leave you with one more quote. It's a bit of a lengthy one. The important thing is not to stop questioning. Curiosity has its own reason for existing. One cannot help but be in awe of when he contemplates the mysteries of eternity, of life, of the marvelous structure of reality. It is enough if one tries merely to comprehend a little of this mystery every day. Never lose a holy curiosity. Albert Einstein.